My question is, do you believe? No. Do you believe in extraterrestrials? Now, I'm meaning by beings, not just bacteria. I'm actually talking. You think they're little? I think maybe little blue men or little green amoebas or thingies or something like that. I want you to raise your hand if you believe that somewhere out there are other life forms of shapes and figure. All right, hold on. Let me count. Devin, are you raising your hand or not raising? Okay, put your hands down. If you do not believe that there are other creatures somewhere out in the universe flip-flopping around and listening to music and playing video games or morphing into metal shapes and looking for people named Sarah. Thank you. Terminator. You go Sarah Connor. I did. I know. Raise your hand if your answer is no, or thumbs up, and we'll do the heads up, 7-up thing, and all that. So. All right, Devin is twirling, so he's already answered. All right, you may stop and look up again, and I will give you the results. Okay, so now first hour was even more skewed out. I think it was like 26 to 2. I want to say it was. Or something. But anyway, so what that means is you've got a probability of success and a probability of failure for a very simple question. Now, in this case, our probability. Oh, I've already calculated my stuff in there. This was an anonymous survey. So, ladies and gentlemen, in this case here, it says that the probability of success would be 25 out of 30. Are we okay with that? What is that? 1/6? Yeah. Which means the probability of failure would be 5/6. Oh yeah, math is hard. Good morning. I was looking at it goes in there. Good morning, ladies and gentlemen. I will be your tour guide on how not to do fractions. I tried. Decimals then. Guys, come on. Decimals. 5/6 is a decimals. What? You have a calculator. I just have a brain that doesn't work right half the time. All right. Means failure is 17%. In other words, failure is not an option, but in this case it is. So what we do with binomial experiments is that if you know the answer to, if you get into binomial stuff and you get basically a subset value of some sort of a baseline data set. In this case, we're looking at our baseline of probability that you believe in UFOs or little green men or people named Marvin the Martian would be an 83%. Now, when we get into it, then we can start talking about it in terms of large scale. And I'm going to switch from our values to what they use in the textbook so you can follow where these numbers are coming and going. In the textbook, what they've used is oh, I lost it. There we go. They used the value of 37% of adults believe in UFOs. So I can't see him. He has those glasses on. So what we do here is if we survey 6 people out of adult population, and we know that there is a 36 or 37% chance of somebody believing in a UFO. What do you do if you want to figure out that if the randomly number of people that 2 out of the 6 will believe in them? What's the probability that 2 out of a randomly selected 2 people will believe in UFOs? And this is where binomial distribution comes into. Binomial distribution has this awesome formula. Like I said, bunch of probabilities. It looks like this. Probability of k successes equals NCK e to the k 1 minus p to the n minus k. So like I said, there's a lot of button pressing to the calculator. No, because there's a button on your calculator. There's a button on your calculator that does this. There's a button on your calculator that does what's called a binomial PDF function. A binomial PDF is, we're going to look at 2 things today. We're going to look at what's called a binomial PDF and a binomial CDF. And either one of them, they both do the same thing, but one does one thing a little bit differently. That made no sense at all. They're different, but kind of the same. A binomial PDF function button on your calculator will find an exact value. Your binomial PDF finds exact values. But you're thinking, well, Murphy, where's this button that says binomial PDF? Well, wait, I'll tell you. You can go catalog, it's a little bit, if you know how to find it, it's easier. What we do is we hit second bars. Bars. It's the button next to clear. Bars. V-A-R-S. And what we're going to do is we're going to scroll through and we're looking for something that says Bino PDF. And it's quicker if you go up. Binomial PDF. Binomial PDF. It just means it's a binomial distribution that we're doing for P for an exact value. Okay? Now, I want you to hit the button that says enter. And it comes up with this. I'm going to talk about that. So we'll use this as our. We have, as of right now, we have this info. We have the number of trials, a p-value, an x value, and it says paste. Well, what we're talking about here is this. The number of trials, this trials is your n value. Your p-value is your percent, as a decimal. Your x value in your textbook is what k equals. Think of it as your expected value. So in our calculator here, I would put in number of trials would be 6. Percent is 0.37. How many do I expect? I expect 2. Okay. Yes, ma'am. It's saying in this case, it's saying for the expected, how many do you want to have successes of? How many are there? I want exactly 2 people out of 6 to believe in UFOs. What's the probability I randomly select 2 people out of 6? If I know that a subset of adults believe that there's 37%, what does that get? You use this stuff a lot of times when you think about success failure. Think about things on a conveyor belt. If you're manufacturing, light bulbs, the light bulb's either gonna work or it's not gonna work. There's either success or failure. So what they do here is they use this in terms of sample testing of how many would I have to allow to go through that I know I have a number of successes. I know the failure rate is 0.2% of light bulbs don't work out of the box. Where do I have to draw the line of doing that? That's where a lot of statistical inferences come from. That's where stats, when you get into it, there's so much going on, and we're just barely scratching the surface of what certain things you can do. because we have 3 days. So in your calculator, if you type it in, we have trials with 6, p-value is 0.37, your expected value was 2. There is a way of pasting things to lists to actually create histograms and do all that stuff. Yeah, we're not going to do any of that, so don't worry about it. So you just hit enter one more time, and you come back to this screen here. Now, in your calculator, that means that this is your N, this is your P, and that's your K. That's what it stands for in the parentheses. So what I do then is hit enter. So that tells me I have a 32% chance that 2 people out of the 6 randomly selected will actually believe in UFOs. Just like we've been doing, I just keep it as a decimals, 2 decimals, and just keep it at that. You don't have to switch to percents. That's one extra step. You don't have to go to what do you call it, the fractions or anything. You just say 0.32. I'm cool with that. It works. We're not like trying to actually find Martians. Great conversation. I'm glad we had this time. Thanks for not stabbing with your pencil. It's very nice of you to switch into your hand at the last moment. I'm so kind. Yeah, if you didn't know what this was, it's a UFO. Devin, I threw a pen. Did you see that? Okay. So, ladies and gentlemen, I'm going to continue to use this same example to describe what's going on. Yeah. What? Bless you. I'm going to use the same example to describe what's the difference between a binomial PDF function versus a binomial CDF function. A binomial PDF function finds a k equals some exact number. So in our example, we had an n was 6, the p was 0.37, and we wanted to know that n equals to the k equal 2. A binomial CDF, what that does, it stands for cumulative distribution function, which means if it's cumulative, it's going to add up specific values to where you tell it to. So if I'm using the same example of randomly selecting 6 people, I could say, what is the probability that I find our k value is less than or equal to 4 people believe in that. So how many trials do I have? 6. If there are 6 trials, that means I could have nobody, 1 buddy, 2 buddies, 3 buddies, 4 buddies, 5 buddies, or 6 buddies believing in that. What I mean is 0 people, 1 person, 2 people, and so on and so on. So what I'm looking at is I can take this CDF function and it will sum what's the probability that nobody believes in it, 1 person, 2 people, and so on and so on. It does the calculation for us, as opposed to having to do a binomial PDF for 1, 2, 3, and 4, and 0. Instead of doing it 5 times and adding it up, it does it for us. Now, in the textbook, we used to, back in my day, before we had these fancy calculators, we actually had to go through the process of we literally had to create lists in our calculator and type all of this in. That's what I'm talking about. No, not gonna happen. So what we do now is, instead of typing all of that in and then adding up what all these equal together, we now know that we can use our calculator to math it. Because what a CDF function does, it will sum from 0, whatever number you tell it to. It always starts at 0 and adds up to whatever value you give it to. So if I'm trying to figure out what's the probability of at most 4 people believing, that means nobody can believe, 1 person can believe, 2 people can believe, 3 and 4. Does that make sense? So I would do a CDF function and I would type in 4 because it would add up from 0 to 4. So how do you find the CDF? Well, it happens to be directly underneath the PDF. Oops, wrong button. Second, bars. Up. Again, the trials is your n value. In this case, I have 6. Our p-value, I'm using the exact same example of 0.37. And then I'm asking for it to sum up to 4. And now it says binomial CDF function in the calculator. It means all the same, n, p, and k, what's going to add up to and include. Hit enter. And the probability that at most 4 people will believe in UFOs, if I have out of 6, is 97%, or 0.97. Yes, ma'am. Okay. The k is the x value, and that works with, that's going to work for either of them, but you have to be careful with CDF functions, and that's why I wanted to go to here. This is great when it's less than. When it's greater than, let's say I want to figure out what's greater than 4. If I want to figure out what's greater than 4, if I want to figure out, that means I'd have to figure out greater than or equal to would be 4, 5, and 6. You okay with that? It would be how many, what's the probability that exactly 4, exactly 5, or exactly 6 would happen? And if I do a CDF, though, it's only going to count up to something. So if I'm going through all of this, basically remember, 100% of your data is going to fall within that for trials. So what I can do is I can figure out what it is from 0 to 3, take 1 minus that, the complement, to figure out the other side. Okay? Because if I go 0 to 3 on a CDF, and what's nice is once you get a CDF or a PDF in your calculator, you just go back up and overwrite it. It's a little bit quicker than having to go through all the buttons there. But just gotta remember which one you're using. So I know I'm gonna use a CDF, and watch what this does. If I go up here and I change it to the last value being a 3. Oops. There we go. That means that if I go from 0, 1, 2, and 3, nobody believes, 1 person believes, 2 people believes, 3 people believe, 85.86 believe, which means how many are left for 4, 5, and 6? 0.14, right? So what we do is this, 1 minus my answer. Oops. %, would be the 4, 5, and 6. CDF, what it does is that if you're looking for a greater than, you go to one value less and you do a complement. If it's a less than, you do it, you set it to that value, and it sums up to the number. Yes, ma'am. Yep. So what we'll do here is this. When we have a CDF, if it is a a k is less than or equal to some number, use the number. If k is greater than or equal to a number, you're going to set it up as 1 minus the CDF function of, what was it, n, p, and then this will be k minus 1. Whatever that k value is. So it's only one of two ways to make it work. If you're using a less than, just use the number. Less than or equal to, use the number. If it is greater than or equal to, you do 1 minus the number that's in there. And it's just boop, 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 on the buttons on the calculator. That's really all. Or Martians. Boop, 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 boop. I don't know if they have antennas, but I just made sure they did. That was fun. So if I look at this, if I do this one, a PDF would say k equals 3. A CDF always has less than or equal to or greater than equal to. So is this one going to be a CDF or a PDF? CDF, good. So it's going to be a CDF. Is it a less than equal to or a greater than equal to? It's greater than equal to. All right, so that means if it's a greater than equal to, what do I have to put out in front of the CDF? 1 minus. Remember, this is 1 minus. I know it's binomial CDF, but you guys okay with me just writing CDF, right? Now, how many trials are there? 5. What's the p-value? 0.2. And now what do I put in for the k value? 2. There you go. Beep boop, beep doop, beep doop, boop, and there's your answers. Well, once you put it all together, yes. What's that? Oh, no. Your k value was 3, so I subtracted 1 to put that here. Yeah. Okay. And then you press a bunch of buttons, and what do you get? Was it 5? Yay? That's really the only difference here. PDFs, you find the exact. CDFs, something. Bye, Devin. Here, if you run right down, it's 7:42. Columbus sailed the ocean blue. I said 12 through 34. Did I say this one? I don't remember what I wrote down. 36, 37. Oh, you left. Is that what I wrote down? Bam! Yep. If it's in less than or equal to, it's just whatever the value is. If it's greater than or equal to, you do 1 minus whatever that k is, and you run it. You do 1 minus the whole thing, but then this value here is 1 less than that. Because if that was that, then this would have been a 3. Okay? Yeah, or you can type it directly in your calculator just like this. Yeah, it worked out to be, what was it, 0.05? Yeah, something 794 or something. Yeah, that's what it was. Yeah. Yeah, there's really not much to this at all. I mean, if you type in that binomial CDF of that first, and then hit enter, and then just do 1 minus that, whatever the answer was, you'll get the same thing. So it's super easy. Yes, ma'am. Good, I didn't want to help you. Good conversation. I was joking, I would have helped you. I'm hungry. Get my carrots. Hey, stop throwing stuff. You guys are slobs. What do you got, Flo?